Hello everyone, welcome to the verse. Thank you for being here. This video is going to be a bit different from what I've published so far. For example, in comparison to my previous published videos, this video is more somewhat academically driven, more analysis oriented. And without further ado, let's dive into it. What you're staring at, for those of you who are not familiar, is a Jupyter notebook, basically a tool for using Python to conduct data analysis and so forth. Over here is a set of statements, charged statements, as you can see, popular slogans we are all too familiar with, right? Just do it, make America great, eat the rich, etc. I'm sure you can see. And then after that, subsequently, is the set of complex statements. As you can see, they're a lot deeper, more philosophical, and the noise is established, and so on. Providers are used who are mostly working with Grok, but Google is also being worked with. Actually, no. With respect to CCI, all models are being tested from Google and Grok. Well, not every single one they've ever created, just everything listed here, as you can see, and listed here. Now, just a quick reminder, this tests the cognitive construct index. It gets the score, the CCI score, which is the cost or weight of a thought. It's denoised and filtered, basically the filtration being that of noise, such as Wi-Fi speed, slowdowns, and so forth, or whatever other web traffic that slows your process, your bandwidth, basically. And if we look at the scores across providers, Google, in this instance, across 5 trials, scored higher, had higher CCI scores with respect to charged statements. Let's run another test. 5 trials are being initialized. One thing I won't mention in the meantime, because it does take a little bit, a couple seconds, is that across several tests that I ran previously, it was always the charged statements. Well, not always. Usually the charged statements that had higher CCI scores for large language models. I think this is because, well, this time being an exception, right? As you can see, complex statements. But I think because this is due to large language models being trained on literary works that authors, sadly, don't get credited for. We've all heard the problems and the ethical issues regarding that, right? Now, again, the CCI score is on a scale of 0 to 1. As you can see, the highest CCI scores is complex statement. I am a lie that always speaks the truth. It's scored at 0.001. With respect to the CCI scale, that's not bad. The closer to 1 the score, the more complex it is. And then over here it denotes how far from noise floor these values are. As you can see, not very far. But some of them do have a higher token cost, which is interesting. The CCI formula will be listed in the description. Will be shown in the description of this video, so don't sweat that part. Also, above all, from aside from the CCI score, this algorithm performs a metacognitive analysis. Now, this is where it gets interesting, because over here, let me just go back to where the metacognitive analyses are. So, over here, you have a Grok response is initiated. The prompt is explain in 2 sentences how this set of statements, complex statements, differs from this, charged statements. for those of you who are not familiar with programming or are a bit rusty, bear in mind, in this prompt, it does not know these are complex statements. Like, it is not like told that these are complex statements, and it is not told that these are charged statements, right? Complex and charged. These are labels that are used to define a set of constants. Okay, as you can see here, complex is the set of these statements, charged is the set of these statements. So it's not seeing the variable name definition, it's not seeing the variable name, it's seeing the definition assigned to the variable name, which is a set. Okay, very, very important distinction to be made here. Now, as you can see, that's what's happening here. Okay, just to highlight. All right, now, here's the cool part. I create another instance where Grok responds to its response. Okay, so as you can see, there's Grok response. So it's going to say ascertain and rethink these specific responses you made as shown here. Grok response, Grok response. Bear in mind, Grok response gets stored in this list, Grok content. Not Google content, I'm sorry. And then its metacognitive responses, right, where it rethinks its statements, gets stored in this list. Okay. Now, of course, you'll see a bunch of, Boolean and logic and loops and shit, all that shit. I had to put a timer so that way I wouldn't reach my daily quota with the the models, because there's no way in hell I'm going to pay a premium just to run these tests. Not on my budget. Now, let us take a look at the different files. A new file is saved for every metacognitive analysis. Now, of course, let me just give you a quick explanation as to what metacognition is. Metacognition is the process of thinking about your thoughts. Okay? An example. Double checking an answer on a test. That's metacognition, as opposed to cognition, which is just answering it outright and doing the processing in your head, right? If I tell you 2 plus 2, if I ask you what 2 plus 2 is, you're going to do that math really quick in your head. 2 plus 2 equals 4, right? That's cognition. Metacognition is if I ask you what's 2 plus 2, you go, it's 4, but hold on, let me think about that for a second. And then you go through all the steps and you write them down. That's metacognition. Now, of course, you need help if you need to use metacognitive skills to think about what 2 plus 2 is. Anyway, here is one of my logs, right? Right, so as you can see, metacognition. Of course, let me just double check here. So it's going to zip through these. It's precognitive inputs and then the actual content. But that's actually an error, I think. Nah. Yeah, audio. Yeah. No, that's not an error. I'm sorry. So the prompt, all right, which we see here, okay? Prompt zips through the metacognitive inputs. Okay. And that is written down. Right. So, first, in this file, not in the program's order, but in the file and how it's written, that order. Okay, the program tells the model to look at its previous input, and as you can see, it re-examines this. Okay, it examines its initial examination, or it re-examines its examination, right? which is interesting. And then the response, which is here. I probably need to change the formatting because if it's unclear to me, I'm pretty sure it's going to be unclear to you guys. So I do apologize in advance. First set of statements consists. All right, so essentially A/B testing is being conducted here, where it's taking its initial response to the first prompt, right, to where it's looking at the complex and charged statements, right, and then it's looking at its responses to complex and charged statements. Right. So now, what's the point of this? Well, to see if the model can think metacognitively. Now, of course, this isn't wildly complex or impressive, but it is the start of data that will be shared. I have shared some works. I shared a paper earlier in a previous post. This is actually going to be a thesis. This is a thesis that I'm working on, which is a thesis being or undergrad research, I should say, being a measurement of the electrical or potential electrical nature of linguistic constructs, or language as a parasitic entity. This attempts to bring physical proof. Now, this is where the professional deviates from the fringe. Okay, most of the content I've published so far has been fringe. This is actual work that I'm doing, that I'm going to bring forth to professors, research papers, and so forth that I am writing. And yeah, and also this is not scripted. As you can see, I'm stuttering like fucking crazy throughout this video, so pardon that. I'm stumbling and all that shit. You know, basically things you don't want to do if you're trying to present something professionally. Maybe the next academic or professional video will be a PowerPoint presentation with a script, so that many of you guys will not have to deal with my terrible tangents. But I just wanted to share this video because I understand it is important. I believe, what's that quote? Carl Sagan said, extraordinary claims require extraordinary evidence or proof, right? But basically, the bigger the claim, the bigger the evidence you have to share, right? For every claim you make, there has to be proportional evidence. So that's what this is. So the other videos so far were pretty much just bullshit entertainment. My own or pseudo-academic drivel or tangent or fantasy, right? But this is where the fringe becomes isolated from all. Not the fringe, but the this is basically fact, and the other video is just fiction, speculative fiction, I should say. No theatrics here. Right. And yeah, that's pretty much it. As you can see, it's responding to it's metacognitively responding to its different responses differently. In a non-homogeneous fashion, so to speak. Yeah. In any case, I will share these logs in a drive, and all of you guys will be able to download them and peruse them as much as you like. And for future reference, please feel free to hype, like, subscribe. Feel free to participate in open discussions. I have a Discord in my profile. Please feel free to join and discuss. I had a guy ask me, I didn't have the Discord set up, or I think I did, but the link expired. I forgot to make it, permanent. What else? Or feel free to just comment. And yeah, because this is definitely interesting stuff, where these large language models are going to take us. If language is indeed parasitic, or if it's a parasite or some kind of an organism, what the fuck does that mean for large language models? I mean, really, right? So if we take that concept and extend it there, then I mean, we're in we're in for some interesting times. I'll just put it that way. Anyways, thank you all, and I look forward to hearing from you.